This is half past paper week 27 for the foundation tier, calculator paper this week, and we're doing all of the odd numbers of this paper. These are all the topics that we're going to do and how many marks they're worth. Total 42 marks instead of the full 80 that would be on a paper. So question number 1, write down the value of the 4 in the number 542.3. Now that 4 is worth 40. So 40 here would get you the mark, or you can say 4 tens. A lot of students just write tens because it is the tens column, but they want to know what is that 4 worth. So 4 tens or 40 is your answer there. For question number 3, change 4,560 grams into kilograms. Well, we know that 1,000 grams is a kilogram. So if I'm going from grams to kilograms, I'm dividing by 1,000. So your answer there is 4.56. For part B, change 7.3 metres into millimetres. Well, 100 centimetres is a metre. So if you're going from metres to centimetres, you are timesing by 100. And then we know that 1 centimetre is 10 millimetres. So centimetres to millimetres is going to be times by another 10. So we're timesing by 100, which would be 730, and then timesing that by 10, so that is 7,300 millimetres altogether. Question number 5, write 0.31 as a fraction. So that is the digits 31, but 31 would be here, and each of those values has moved 2 place value columns to the right, so we've divided it by 100. 31 divided by 100 is your answer there for 1 mark. Question number 7. Simplify 3m, take away m. Now remember, an m on its own is the same as 1m. Take away another 1m, add 3m. So 3 take away 1 leaves me with 1m, and then I'm adding 3m back on, so 4m is our answer there. For part B, simplify 2 times n times p times 4, and we can do the 2 times 4 to make 8. And then when we multiply, we just write those letters next to each other. Letters next to each other in algebra means they are multiplying together. So 8np is the same as that. You can put 8pn, but we tend to go alphabetical order, so np would be preferred there. Question number 9. The nth term of a sequence is 3n add 4. Now 3n add 4 is the 3 times table, but 4 bigger. So if we had the 3 times table, 3, 6, 9, 12, and so on, we want to go 4 bigger than each of those numbers. So if we added 4, we'd get the sequence 7, adding 4 would give me 10, adding 4 would give me 13, and adding 4 would give me 16. So this is the sequence that we've got, and you could carry that on, and so it's going to be 19, and then it's going to be 22, and then it's going to be 25, and so on, and you can show that 21 is not in that sequence. But crucially, what I would probably do here is say that, well, for it to be in the sequence 3n add 4, we have to times the number by 3 and then add 4 to it. So with 21, if we work backwards and we take away 4, we get 17. And then we can say 17 is not in the 3 times table. For part B, here are the first 3 terms of a different sequence, 1, 2, 4. Write down 2 numbers that could be the 4th and the 5th term of the sequence. So the 4th term of the sequence and the 5th term of the sequence would be the next 2 numbers. And it could be, going from 1 to 2 and 2 to 4, could be that we're timesing by 2 each time. In which case, I would say 8 and 16 would be my next 2 values. And we could say times by 2 each time. That would be correct. But also, if we did it a slightly different way, you could say that they've added 1 and then added 2, and then they could add 3, and then they could add 4, which would give me 7 and 11 as my next 2 answers. So we could say 7, 11, add an extra 1 each time, and they can see the +1, +2, +3, +4 up there, so that's made that nice and clear. There we go, so you could have that as well. Either of those would have been absolutely fine for the mark. Question number 11. Adam gets a bonus of 30% of £80. Katie gets a bonus of £28. Work out the difference between the bonus Adam gets and the bonus Katie gets. Now, we do have a calculator for this, so you could do 30% of 80 in your calculator by doing 0.3, because that's 30% as a decimal, times by 80, and that would give you 24. Or you can say, well, 10% to get that, we divide by 10. 80 divided by 10 is 8. So 10% is 8, which means that 30% is 3 of those, So 8 times 3 is 24. So 24 is what Adam gets. And Katie, we know, gets £28. So the difference between what they get, we're going to do 28, take away 24, and our answer there is £4 difference. Question number 13. A square has an area of 81 centimetres squared. Find the perimeter of the square. Now, to work out the area, we know that it's base times height. But because it's a square, both of those values must be the same. So something times something is 81, but both these numbers need to be the same. The square root of 81 will give you that value. That is 9. 9 times 9 is 81. So it must have a width of 9 and a height of 9. And therefore this side is 9 as well, and this side is 9 as well. We needed those lengths because they've asked me to find the perimeter, and the perimeter is the distance around the outside. So I'm going to do 9, add 9, add 9, add 9, or 9 times 4, and that is 36 centimetres. Then the diagram shows a right-angled triangle and a parallelogram. The area of the parallelogram is 5 times the area of the triangle. The perpendicular height of the parallelogram is h. Find the value of h. So first we're going to work out the area of the triangle, which is base times height divided by 2. So 16 times 9 divided by 2. To do 16 times 9, I'm going to do 9 times 6, which is 54. 9 times 1 is 9. Add the 5 is 14. And then we've got 144, but we need to divide that by 2. And that is 72. So the area of this triangle is 72 centimetres squared. And then we're going to multiply that by 5 to get the area of the parallelogram. So 72 times by 5. 5 times 2 is 10. And 5 times 7 is 35. Add the 1 is 36. So this parallelogram has an area of 360 centimetres squared. Now to get the area of a parallelogram, you just do base times by height. So 30 times by h equals 360, and then we can divide by 30 to work backwards and find out what h is. So 360 divided by 30. If you get a tricky division, you can always write it as a fraction and then simplify it. Both those values are in the 10 times table, so I could simplify it to 36 divided by 3, which is 12, or you can just use your calculator. So the height there was 12 centimetres. Question number 15. Remy invests £600 for 5 years in a savings account. By the end of the 5 years, he's received a total of £75 simple interest. Work out the annual rate of simple interest. So compound interest is when it builds up and it adds on to the previous amount. But for simple interest, we get the same amount every year. So if he's got £75 over 5 years, we can divide that by 5, which is £15, which means each year, the annual rate, he's going to get £15 interest for every single year. So £15, what percentage is that? Now to work that out, we're going to do 15 out of 600, because that's how much money he's putting in. And we're going to times that value by 100 to get it as a percentage. So 15 out of 600 times by 100, type that in your calculator, and that gives you an answer of 2.5. So the percentage simple interest rate is 2.5%. Question number 17. Adrian is going to make concrete. He's going to use 180 kilograms of cement, 375 kilograms of sand, and 1,080 kilograms of stone. Cement, sand, and stone are sold in bags, and those are the weights of each bag. Adrian already has 10 bags of cement, 20 bags of sand, and 20 bags of stone. Work out what bags he needs to buy to make the concrete. So if he's got 10 bags of cement, he's got 10 lots of 25, because 25 is how much is in one bag, and that is 250 kilograms. Now he needs 180 kilograms of cement, so he's all good. He's got plenty of cement. Then 20 bags of sand is 20 times 22.5. 20 times by 22.5 is going to be 450 kilograms. And he needs 375, so he's got enough of that. Now for bags of stone, it's 20 times 50, and that is going to be 1,000 kilograms, but he needs 1,080. So he doesn't quite have enough stone. So he needs an extra 80 kilograms of stone. And that's not going to come from one bag, and 2 bags would be 100. So you can't buy 1 and a bit bags. He's going to need to buy 2 bags, so he's definitely got enough. So needs 2 more bags of stone. That would be my answer. There we go. Question number 19. Solve 3 lots of x minus 4 is 12. Now you could start by dividing by 3 here, but that doesn't always go in exactly. So what I'm going to do is expand out that bracket. 3 lots of x and 3 lots of minus 4 is 3x minus 12. And that needs to equal 12. Now, what you do to one side of this dotted line, you're going to do to the other. I want to get the x on its own. I'm going to start by getting rid of the minus 12, and to do that, I'm going to add 12 to both sides. So 3x is equal to 24, and 3x means 3 lots of x. So to split that up and just get x on its own, I need to divide by 3. So I also need to divide this side by 3, and that is 8. So x equals 8 is our answer there. Then for part B, factorise fully 9b minus 3b squared. What have they got in common? Well, they've both got a b and they're both in the 3 times table. So I'm going to put 3b outside of a bracket. And then I need to think what would need to multiply with that 3b to give me the first term of 9b. 3b times 3 is going to make that happen. Then we need a subtract here in the middle, because we've got a subtract here. And then 3b times what would get me 3b squared. Now remember, 3b squared is 3 times b, because that b being squared is timesing it by itself. So I've got 3b on the outside, I just need another b here to factorise it fully. Now the factorise fully was a clue that there was more than one thing to come outside the bracket. So if you just took 3 on the outside, and you left that on the inside, that's how you're going to get 1 mark there. Because you have factorised, it's correct, you've taken it outside the bracket, but you've not fully factorised. We always take as much outside the bracket as we can. So that would only get you 1 mark. So you don't want to do that. You want to take as much outside the bracket as you can. And that would be for 2 marks. Question number 21. Sean has information about the height in centimetres and the weight in kilograms of each of 10 rugby players. He's asked to draw a scatter graph and a line of best fit for this information. Here is his answer. Okay, Sean has plotted the points accurately. Write down 2 things that are wrong with his answer. So what we need to make sure here is that with a line of best fit, it needs to best represent the data. So his line of best fit should be looking something like that between all of the coordinates, and it doesn't at the minute, does it? So that's no good. So we need to say line of best fit is wrong. I think he's assumed that it needs to go through this bottom left hand corner, and it doesn't. So line of best fit is wrong. It needs to better represent the data. I'm going to go for better represent the data. And then we need to just look at the scale. This is something that they really like to do on exams. So on this side, we've got 85, 90, 95, 100, 105. I'm okay with that, it's going up in 5s. But on this side, we've got 140, 160, 170, 180, 190, 200. So it's going up in 10s there, but here we've got a jump of 20. So I'm going to say the x-axis is not going up by the same amount. And you could really spell that out. You could say 140 to 160 is plus 20, and then 160 to 170 is plus 10. Something like that. There we go. 2 marks. Question number 23. Northern Bank has 2 types of account. Both accounts pay compound interest. We've got the cash savings account and the shares account. Ali invests £2,000 in the cash savings account and Ben invests £1,600 in the shares account. Work out who will get the most interest by the end of 3 years. So with these comparison questions, I like to split the page. So we've got Ali on this side and we've got Ben on this side. Now for compound interest, that means after every year, you're going to get a little bit of extra interest because you're going to get interest on the interest you've already earned the year before. So for Ali, we're going to do £2,000 and we're going to times that by, now, £2,000 is her 100% investment and we're getting an extra 2.5%. So that is 102.5%. To write that as a decimal, that would be 1.025. So we times by 1.025 and we raise that to the power of the number of years, which is 3. So 2,000 times 1.025 to the power of 3 is 2,153.78125, but I would round it to 2 decimal places because it's money. Now, she started with £2,000, so the interest she's earned is £153.78. Now let's have a little look at Ben. He's also starting with 100% of his money and gets an extra 3.5%, so he gets 103.5% interest. As a decimal, we would write that as 1.035. To get from percentage to decimal, you divide by 100. So for Ben, we're going to do 1,600, that's what he's putting in, times by 1.035 to the power of 3. And again, I'm just going to type that in my calculator. This would be a calculator question, and that is £1,773.95, because the next value is an 8, which rounds up. Now, how much interest does he earn? Well, if we take 1,600 away from that, the extra amount of money he earns is £173.95, and therefore that is his interest. So, of the two, who's earned more interest? We're going to say Ben earns more interest. Now, in the third year, the rate of increase for the shares account, so that's this one, is increased to 4% per annum. Does this affect who will get the most interest by the end of 3 years? Give a reason for your answer. So no, it will just mean that Ben gets even more. So he already had the most, and if we raise that interest rate, he's going to get extra money. So no, it will just mean that Ben gets even more. Fabulous. Question number 25. A is the point with coordinates 5, 9, and B is the point with coordinates D, 15. The gradient of the line AB is 3. Work out the value of D. Okay, so for gradient, we do rise divided by run. Now, the rise is how much the y coordinate has changed, and the run is how much the x coordinate has changed. So to go from 9 to 15, it's gone up by 6. So the rise is 6 divided by the run, which we don't know because it's going from 5 to D, which we don't know. And that needs to equal 3. So what does that need to be? Well, that run needs to be 2. It needs to have gone 2 across. So if we're starting at 5, which we can see from that coordinate there, D would need to be 7, so it's gone across by 2. So D is 7. That's one way of doing it, but if that doesn't make sense, let me draw it for you. So let's go 5, 9, so roughly 5, 9, be about there. And then D, 15, so we don't know where it is, but we know it's going to be higher, and we know it's going to be up here because the gradient is 3. So that means for every 1 across, it's going 3 up. So we can see that we don't know how much it's gone across by, but I know that it's gone up from 9 to 15 by 6. Now every 1 across, it needs to go up by 3. So it's going to need to do 2 of those jumps, and therefore 1 across, 1 across. If we've started on 5, D is going to have to be 7. Hopefully that makes sense. So we've gone 6 up, so we needed to go 2 across, because rise divided by run, 6 divided by 2, is what gets us a gradient of 3. So 2 bigger means that D needs to be 7. Question number 27, and we've got standard form, last one on this paper. Write the number 0.00007547 in standard form. So standard form needs to be a digit between 1 and 10. It can be 1, but it can't be 10. So I'm going to use the digits that we've got here, and that's going to be 7.547. Always standard form is times 10 to the power of something. Now, when it's a really, really small number, less than 1, we're going to be dividing by 10, and we achieve that by making the power negative. So I would like the decimal point to be here. Now, obviously, it's the numbers moving, but it's far easier for us to move the decimal point. So how many jumps? 1, 2, 3, 4, 5. So that means we've divided by 10 5 times, which is the same as timesing by 10 to the power of minus 5. So that would go there. For the next one, 3.42 times 10 to the power of 4 means you're going to times by 10, times by 10, times by 10, times by 10. So 3.42, if I times by 10 once, I get 34.2. If I times by 10 again, I get 342. Times by 10 again and times by 10 again means we're going to end up with 2 additional zeros there. So that's going to be 34,000 200. Again, I'm bouncing that decimal point, but it's all of the place values, the digits that are moving into different place value columns, but it's just easier for us to move that decimal point. Okay, and then for part C, work out this. Now I'm actually going to type this exactly as it is in my calculator. So first I'm going to use that fraction button, which you should have on your Casio calculators, and I'm going to put 2.3 times 10 to the power of 4 times 6.7 times 10 to the power of 3. And then I'm going to press that down arrow, come down to the denominator and write 5 times 10 to the power of -8. So you can use your calculator to put in any power that you want. And my answer for that is 3.082 times 10 to the power of 15. 3.082 times 10 to the power of 15. And that's my final answer for that one. So that's standard form, that last topic. Let me know in the comments if you've got any questions on any of the topics that we've done today. I'd love to help you. And I will see you guys next week for week 28.